As the sun rises over the South Pole in September, it provides the spark of energy for chemistry that eats away at the ozone layer.
It's amazing. It's one of the biggest, fastest chemical reactions in the world, driven by sunlight. And very high concentrations of ozone in the stratosphere are reduced by half. Within a month, they go to zero in a certain layer of the atmosphere. The ozone layer is so important in protecting us from ultraviolet radiation. If you remove just a small percentage of the ozone around the world, you're going to affect plant life, you're going to cause cancer increases, you're going to affect plankton formation in the oceans.
So for the ozone hole to form, we need several conditions. We need very cold temperatures, which is what's happening during the winter time over Antarctica. And those very, very cold temperatures, as low as about -109 Fahrenheit, they create the special clouds that are called polar stratospheric clouds. And these clouds contain small particles, ice crystals, and on the surface of these particles there is some special chemistry that happens. And all of these man-made chemicals that we produce, chlorofluorocarbons for example, they become activated, and with the sunlight these chemicals become very active and they start to destroy ozone.
The fast, high-altitude winds of the seasonal Antarctic vortex create the perfect environment for those man-made chemicals to destroy ozone.
It's like putting a match in this 1,000-square-mile pool of high volatile gasoline. It's gone, just like that.
In 2012 so far, about 20 megatons of ozone has been destroyed. That's about the weight of 3 Hoover dams. 2006 was worse. That year, ozone loss totaled 40 megatons, or 6 Hoover dams.
There's two ways that we measure ozone at the South Pole. One is with balloon-borne ozone sondes, that's what I'm involved with. And then there's also a ground-based instrument that looks up at the sun and moon as well to get total column ozone. That's called the Dobson spectrophotometer. Well, NOAA has been measuring ozone with a Dobson spectrophotometer for about 50 years now, and the ozone sondes, the balloon-borne ozone sondes, for 25 years, a little more. These balloon sondes go about 10 miles an hour up through the atmosphere, and they'll reach about 21 miles altitude. And during that 2-hour or so period, it's sending back ozone data, about one line every second, or 1 point every second.
Levels of ozone-depleting chemicals in the atmosphere have plummeted, but they can last decades. NOAA's ozone measurements in the Antarctic spring help us understand ozone depletion where it is the most severe, and where we could detect signs of early recovery in the next few decades. In 2011, similar conditions formed over the Arctic in the northern hemisphere. That year, ozone-depleting conditions persisted much longer than usual up north, and the stratosphere was very cold.
As climate warms up, more energy is going to be held near the Earth, so it's going to get colder high up in the atmosphere, the stratosphere. That could cause more of these temperatures getting to -80 and bigger holes. So that is a concern. So the Arctic is being monitored very carefully because there's a lot of people live at that latitude. There's a lot of fisheries. There's a lot of potential harm that can happen in the Arctic.
Well, NOAA is an organization that's a part of a broad range of governmental and university and academic organizations that are keeping track of the ozone layer and doing measurements all around the globe, whether from satellite, ground-based, or balloon-borne. And all these organizations kind of work together in keeping track of the ozone layer. And with all that information coming together, we can get a good idea, a good picture of what we can predict for the future.